A person borrows $15,000 to buy a car. This is very realistic life situation for these people. I'll accept the cars are more expensive now. Maybe it's a used car. Could be wrong. Still, a used car for 15 grand is pretty cheap right now, right? So, person can afford to pay $300 a month. The loan will be repaid in equal monthly payments of 6% annual interest, compounded monthly. How many monthly payments will the person make? So they would give you this formula that I have off to the side here, and everything would be described for you. So you would know the present value of the loan is 15,000. Our regular payments were 300. Square bracket 1 minus round bracket 1 plus the I. They would tell you. Oh, where'd my 1 go? There it is. The I, they would tell you, is the interest rate per compounding period. So you'd have to change your interest rate to a decimal. And since it's compounded monthly, you do 0.06 divided by 12 to the exponent of negative, and n is the time. Close that square bracket over 0.06 to the 12. So we are solving. We are solving for n, which is the number of payments, and the n is in the exponent. So we're going to need to use logs. First thing I'm going to do is I'm going to put a square around that power with n as the exponent. So our preliminary work is to rearrange this all to get that by itself. So the opposite of dividing by 0.06 times 12, I would start by multiplying both sides by 0.06 divided by 12 so that this simplifies. Take out my calculator and do that. And I get 75. Rewrite everything else that's left. Again, I'm going to keep simplifying until I get that power by itself. So next, looks like I could divide both sides by 300. And I would get 0.25 equals, and when I divide by 300, do you see that you just have the square brackets left? So I do not need to write them because they're not holding anything anymore. But be a little bit careful because again, here's my power. Okay, most people see that they need to move the 1 over next. So I'm going to subtract 1 on both sides. Doing that will give me negative 0.75. But I find when people subtract 1, that sometimes they make the following mistake. Right? I subtracted 1 on both sides. That would just make the 1 go away. Does that make the negative sign go away? No, that negative sign is still there. And technically, I'm really close right now, but technically, I still haven't got that power by itself because of that negative sign. We can multiply both sides by a negative. I can change these both to positives as a result. Then I get rid of my negative sign. Now I have finally got my power by itself. All that preliminary algebra, now I can start to use logs. I can take the log of both sides, so log of 0.75 equals log 1 plus 0.06 over 12 to the negative n. And at this point, I can say that exponent can come out in front. So your negative n log 1 plus 0.06 divided by 12. And now I can get my n by itself by taking this 0.75 and dividing by, what do I have to divide by? I have to divide by the negative and the log. This one I'm gonna do on my calculator here.
Can you take a natural log? Like, does it matter what's
It doesn't matter if you did log or natural log. Your answer when you type it into your calculator will be exactly the same. Sorry. Let you see that. Let you write that down. Then I'll type it into the calculator. We'll get our answer. All right, I'll pull my calculator up now. So I had log or natural log of 0.75 divided by negative log. And here, make sure you're using the negative sign, not the subtract sign, because your calculator will get mad at you. 1 plus 0.06 divided by 12. And I get 57.680 for n. Now I'm going to read, does it ask me to round? How many monthly payments? Sounds like you're rounding. So it's really important, show your decimal places. And then if you think you need to round in this case, they'll make 58 payments. Even if it was 57.1. Technically, they'll make 57 full payments, and their 58th payment will be a little bit smaller because they only owe a portion of it. Does that make sense? So the person will make 58 payments. Again, anytime you're solving these equations, right, I can take this, I can either use the answer button or I can use my store button. I'm going to store this answer as X, and I can check if I rewrote the original question out. You remember the original question had 300 square bracket 1 minus round bracket 1 plus 0.06 divided by 12 to the exponent of negative. And then I've solved it. I'm going to check. I'm going to plug in that X. Close that bracket. All over 0.06 divided by 12. If I get 15,000, then I did it right. If I don't get 15,000, then everything I taught you in the last 5 minutes has been wasted time. And starting to sweat here. Yes. Okay. It worked. So again, anytime you solve for equation using logs, you can take your answer, you can plug it back in, and you either get the relief of I did it right, or the horror of I have to do it again. Now, last time I showed you on the graphing calculator, under apps, they have the finance thing, they have the TVM solver. And you can do so much with this. So what did we do? We had a 6% interest. This time, and I talked about this last time, anytime that you are given something, it goes as positive. Anytime you have to take money from your pocket and pay it off, it goes in as negative. So when you get a loan, that 15,000, technically, they gave you have the car. You've already got all $15,000 because you have the car. You can't really put it in your pocket, but you have it. So it goes in as a positive value. But your payments of $300 per month, those will go in as negative. In the future, you want to owe no more money. So we'll make that 0. We're making monthly payments, and it was compounded monthly. So we do 12 and 12, and then your calculator can go up to this part and go alpha solve, and you get that same number really quickly, which is nice. In fact, you can find out, and this is an important thing, this is why I think this math that we're doing right now is super important for you. You should want, you should want to know how much you pay for this car. they tell you, right? You're making 57.6 payments. You see I'm timesing by 300 because each of your payments is 300. I push enter here. I find out that I will pay an extra $2,300 for my car. That's what it's gonna cost me to buy that car. Extra interest. You have to make this, you have to make a decision. Is that worth it for you? You need the car to work. You work, you get money. Right? I have to afford to pay extra for this car because I need it to work. Who takes advantage? Either the financial committee, the financial institution at the, like most used car dealerships, they're like, and you can't afford it, welcome to our finance department. Because they know they can make money from you a second way as well by charging you that interest. So sometimes you might be like, I can get the $15,000 from my bank at 5%. So then it's better. Or if you can negotiate. Now, the reason I want to use this program now for a bit is because probably most of you, your first loan will be for a car. That's like probably the first thing you're gonna buy. But then a little bit later, you're going to buy a house. Houses are a lot more expensive. And here I want to show you how you can use a program like this to find out how much it costs and understand, because I believe understanding how interest rates work in this can save you tons of money over your lifetime. In fact, I would argue that in my lifetime, I have saved, compared to the average person, $50,000 to $100,000, knowing how interest rates work. That's a lot of money to save. So, how do we come up with this? Well, we're gonna go through a scenario. Most mortgages last for 25 years. So you make monthly payments for 25 years. You will make 300 payments in the end. We're gonna start off with an interest rate of 4%. That would be really good right now, actually. If you got 4% for a mortgage, it would be really good. Houses are expensive, right? So let's say we're buying a starter house for $350,000. But you needed to have a down payment, so you had to save up $50,000 already. So your mortgage will say you're gonna buy a house that is worth $300,000. That goes in as a positive number because you get the house. In the future, you want it to be zero. Actually, in Canada, it is a requirement that mortgages are only compounded twice per year. So even though I'm making monthly payments, it's only compounded twice per year. And in the future, it's gonna be a value of zero. What we can do here is we can go to the payment and I can go alpha solve. How much is this gonna cost me per month? Can I afford to buy this house? So right now, $1,600 a month is going to go towards your house. For 25 years, you're gonna have to do this. That's a lot of money, isn't it? You have to get a pretty good job to get this house, right? We can take this number and you can go, if I pay this for 25 years, times 300. Wow. The $300,000 house that you bought, at the end of it, you will pay $473,000 for it. That's our starting point, 473 already here. Okay? $173,000 goes to the bank. Now, on a positive side, unlike the car, once you're done paying it off, is not worth as much as you paid for it. It depreciates in value. Whereas a house, most likely, this $300,000 house in 25 years will be worth at least 473. So in that sense, even though you paid for it, you at least have something that's worth that much. It doesn't go down in value. So that's a good thing. But we started with about $473,000. Okay? Now, I'm going to show you things that you can do that can save you money over time. Because paying an extra $173,000 isn't the greatest. First of all, if you take the time to really look around at mortgages and negotiate, and even if you could only get 0.25 off, right? You're like, maybe you're married already and your spouse is like, you really took all day to work on this? And you're like, yeah, I got 0.25 off. They're like, wow, you spent 8 hours doing this? Okay, well, how much are your payments now? Instead of $1,580, they're $1,537. Times this by 300. $461. $461. Would you work an 8-hour day for 12 grand? If I offered you anybody a job, hey, 1 day's work, you have to work hard. 12 grand. I know. I would go pretty. It's like there's some pretty bad jobs. I think. Yeah. Okay. 12 grand. Yeah, I'll do that. Right. So.
It's not a lot, I wouldn't.
No, that's a good chunk of money, right? So now we've already saved 12 grand, and all we did was get an interest rate that was a little bit better, or take our time to go around to different banks and negotiate these things. Okay, that's number one. Saved us 461 down to 461. Now, next thing. When you buy your first house and you get your payment, usually you're in the beginnings of a job and this is like, oh, this is the most we can afford. But what happens over time with lots of jobs is you get raises. I'm making my salary now compared to what I started is worth over double than what I started. That's just a good thing, right? It's gone up over the years. Negotiations, I'm making way more than when I started. And when you start to make more money, you have a choice. Some people are like, I'm making more money, I'm buying new shoes, I'm going to more jet skiings, I'm going to more concerts, and I'm spending more on entertainment. And that's fine if that's what you want to do. But another option that you have is when you make more money, you have the choice to pay more of your mortgage off. Could that save you money? Let's look and see. So now you just go, we start making more money. Instead of affording $1,500 a month, we can up it to $1,800 a month. And still drink water and eat mac and cheese like we've been doing. Because once you start living on your own, it's like, I remember like, yeah, I'm no longer drinking juice and pop at home because it costs money and I have to pay for it myself. So now I'm drinking more water. Anyways, so I put this up to $1,800. What's that going to do? It's going to reduce the amount of time it takes to pay it off. Right now it was 25 years. I can solve this right now. And I reduced it down 66 payments. That's like 5 years taken off. Not only will I own my house 5 years faster, okay, but now I go down to this amount. Well, I'll do it up here. 234.9, 235 payments. Those payments are not all $1,800. I knocked it down to $423. I'm already 50 grand from where we started with two little things. Getting a little bit better interest rate and making payments a little bit higher. Okay. Another thing that you can do, something that I've done with my mortgages, is they give you the option. They say, would you like to pay every month, or would you like to pay half of this? So now I'm going to go to half of this, negative 900, but instead pay it every 2 weeks. So instead of 12 payments per year, I would have how many payments per year? 52 weeks in a year, 26. My number of payments is gonna be way more because I'm paying more often. Does that make sense? So if I go alpha and solve now, it's gonna take me 454 payments of $900. But just deciding to do it every 2 weeks instead of times by 900, every 2 weeks instead of once a month, 409. That's another 14 grand I just saved. That's crazy. Okay, the reason the every 2 weeks pays more is because in a year, monthly is 12 times. Every 2 weeks is 26 times, but twice a month would only be 24 times. There's going to be 3 months that suck. Because there's 3 months where you have to pay 3 mortgage payments instead of 2 mortgage payments. But over time, that knocked another 14 grand off my total. And just starting from my beginning to my end here, $64,000 taken off. Small things that you can do. And not only did this, what would we're about, you're also done 5 years earlier. You've saved that amount and you're done your mortgage earlier. Could be an advantage. Yes.
So how much would it be if you just bought it without taking out a mortgage? Like if you just had the bought it?
If you just have the money and bought it, you're not gonna pay any interest.
Huh?
Well, it costs you 300,000, and if you happen to have like, oh, what's this in my back? Oh, I forgot. I had this $300,000 wad in my back pocket. It's a lot of. I don't know if you've ever held, like, what's the most money you've ever had all at once. It can start to stack up. 300,000 would be, your pocket would be hurting. Okay? R 7 and 12. The next exponential example that we're going to go through here